So now what we're going to do is we're going to install the Panoptes avatar. We're going to install a development environment for the Panoptes Observatory Control System, or POCS. I don't know how to say it. It's the POCS Observatory Control System, so we can discover new worlds, because that is important. Science is important, right? And I'm installing it on macOS. So what we're going to do is there's a whole bunch of instructions here. We're going to skip on over to the wiki. Boop. And we're going to close all these other tabs I have open. And we are going to go over to the list of documentation. We're going to go right to the macOS development install. And we're going to be following this guide for installing it. I have pretty much a clean High Sierra installation because I just reinstalled my operating system on this computer. And let's get started. So the first thing we're going to do is open up a terminal. Boop. Make it bigger so you can see it. We're going to edit my bash profile using the only editor that the world ever needs. Which is VI, of course. Never need Emacs. We're going to add some environment variables. I guess we're just setting it up var Panoptes. Sure. Let's make it look like a real telescope unit. So now we're going to want to source that profile, and we want to make sure that those variables exist before we start using them on commands that do things like make directories. End user, tender. Okay, so those all exist. So do we have a user? We're going to want to create a user for that. There's something that's missing from here. Let's go ahead and make the Panoptes directory. And then now that we have the pander, so we have a directory here. It's owned by me right now. But we want this to be owned by that user. So I'm going to have to go and add that user. So is there a way for me to easily add a user from the terminal? I've only ever done it via the point and click user interface. Apparently you can. That looks involved. I'm just going to go ahead and create a user. So I'm going to use the system preferences, users and groups, and I'm going to create a new user. Oop. First I'm going to unlock. Oop. So I unlocked that little lock, typed in my password. I'm going to create a new user. And do I want to sandbox them? I'll make them standard user for now. Account name Panoptes. Do they need to be... Are they going to need to be a super user? Because that would be a little bit... That would defeat the purpose of having it as a separate user. I'm assuming that. And then I need to give... Do I need to give them a password? Yeah, I need to give them a password. Oh no, it worked without a password. Okay, so Panoptes is a standard user that has no password. And a flower. Change their icon. Is there like a space person or something? Because that would be so much more appropriate. There's a planet, Earth, but good enough. So now I should be able to change the ownership of Panoptes to pan user. And sure enough, it's owned by Panoptes. So I want to create... I want to be Panoptes, so I'm switching myself over to Panoptes land. And now I can make these directories. but permissions denied because why? Private var not. Interesting. Make dir. Not exactly sure what happened there, but that's okay. So let's make sure that's still working. Oh. My environment variables are probably not set up. Does this user have a home directory? Yes, it does. And when I switch user to Panoptes, all of these were lost. Vim. So I should probably set them all for this user. So I guess what I should prefix this with is I should add another step up here to create a user. And then I don't know if this user has access to Conda. I have access to Conda. I can run it, but I probably can't install any dependency packages. It's kind of funny. I've never actually used macOS, OS 10 as anything other than kind of a single user operating system for me, the developer. So using it in this multi-user mode is different. Okay, now these paths are set up roughly right. These commands all ran. They should probably be re-entrant now. Oh, but Panoptes doesn't have a user, so these commands should all be re-entrant now. Means I should be able to run them. Oh, but it's a sudo command again. And these commands should be re-entrant. Okay, that's good. Next one is setting up Miniconda. So let's go get the Conda information from my profile and copy it over. Did Anaconda really install to the root of this computer? Oh my gosh. Why are scientists all crazy? Of course it installed it in a new root directory on my file system. How did it know my file system was set up in such a way? Oh, whatever. Anaconda, you're weird. I would have liked it to install to user local or something, but whatever. Fortunately, I only have a single file system that mounts everything, so that worked. Just an interesting choice. So let's go on back into. We're back in Panoptes, Vim. Going back into bash profile. We're copying over all the Anaconda stuff so that it can actually find Anaconda. Who owns Anaconda? It's owned by me. So it's a different one. Okay, this is crazy. Okay, so maybe I should give Panoptes its own Miniconda installation. Let's go ahead and set up another Anaconda installation, a Miniconda installation, just for this Panoptes. You know, it's always a good idea to do things like that. Basically, I just took a program off the internet and ran it with bash. Which is, generally something you should proceed with caution whenever you do. Because I'm just, it could do anything on the system. And we'll remove the installation binary. There, okay, so that Anaconda is set up right. Now we want to set up the Panoptes environment. Let's open a new terminal. Where am I? Okay. Make sure we have the right Python running. Python 2 Anaconda. So create that Conda environment. The current user does not have write permissions to required path. User Panoptes Conda packages. ID, I am Panoptes. I should have write permissions. These are all available right now. So Conda create Python sci Jupyter. Does not have write permissions to required path. Is that because this directory doesn't exist? I would expect to be able to directory. Here's a directory. I was just able to touch URLs that text. Apparently that fixed it. It was just looking for that file to exist. So as long as it existed, do stuff. So now it's solving the environment again. But this time it's Miniconda, doing its Miniconda thing. And once that, okay, then we got a bunch of stuff. Yeah, install the world. Permission denied. But why? But why? Permission denied here when creating Conda environment as non-root user. Got a bunch of IO errors trying to install Python widgets. So that got grumpy. Let's just try with none of these things installed. Can I just create one? I guess first is that's the root conda. Dot space slash dot. Okay, so that's the right conda now. That should actually probably be able to install now. Oh wait, but that's not the right thing. I can run the full command. Go ahead and run the full command. Which is just below the screen right now. We're installing a bunch of stuff. Let's see if it's successful this time. And one of the reasons I'm running into a lot of these issues is because this is a sandbox user essentially. And the idea behind this is when you install, like this is essentially an embedded system and we're installing it as a less privileged user so that if there's a security vulnerability in some of the Panoptes software on a deployed unit, that it will reduce the ability of that attacker to like take over the entire telescope. I don't know what they would do. Mine bitcoins on a telescope? Seems like a terrible idea. Install malware. Actually, some of these telescopes have pretty big pipes. So I guess you could use it for denial of service attack. In other words, bad things, none of which we want to happen. We want to reduce their ability to go cause havoc. So once we've created a new environment, this Conda has this really cool ability, like it has its own virtual environment kind of feature set. But now we're going to want to install a bunch of system packages. Those are going to have to happen from my that's going to have to happen from my real. So I don't think I have Homebrew installed. Do not. So I'm going to have to install Homebrew. That's because these are system packages, I have to install them as a user with. This is an even more dangerous thing to do than getting this thing and just piping it to Ruby. Let's take a look at what the script does. While it's installing, I'm going to go pull down. So here's the program it actually runs. I will read it. Got it. Okay, so it's doing stuff. Lots of like output. How to do sudo. This does not look. What's crazy is you can hide like a single line in one of these scripts and cause all sorts of havoc. But you know, generally I just like reading stuff, like at least scanning it before I run it to make sure there's nothing egregiously wrong. Even though I have no real faith that I would actually be able to catch a real troublemaker. It's a pretty long script. It looks like it's on the up and up though. I don't see anything totally awful. So go ahead and install Brew. And it slurps down all this stuff. And again, this is happening as my primary user, essentially my privileged user. Hey, I have Homebrew. So I'm gonna have to install all these packages. Oop. Apparently libz I don't need anymore. Not found. I wonder how many of these are actually required. Because obviously libz is not. Guess we'll see how the rest of the installation goes. And it says, when installing Cairo using Homebrew, you may have to set package config path environment variable manually. To do this, copy and paste this stuff. Let's see if it explodes when it tries to do the Cairo installation. Which it's doing right now. The very exciting parts of installing dependency. Anyway, after this, we'll be doing astrometry stuff. And then cloning down a couple repos. Or if it hung for, like, this is always the thing, is like, how long do I let this sit here before I see if it, I guess I can use activity monitor again to kind of get an idea if it's actually working. Oh, it was still working. A little cache, it was hard to work. Still installing Cairo dependency. Now it's installing Cairo. This is where it reported that I might run into an issue, but I didn't seem to. Go ahead and install a few more of these. Ooh, Swig. Some of these are older libraries. I'm not sure how much I think Swig is not as aggressively. I think I remember running into the fact that it's dead or something. Nope, I'm thinking of a difference. Okay, so with all of those installed, we can go back here and we need this tarball. So where is it installing this stuff? It's installing it into Panda, which means we want this owned by Panoptes. I'm still in my home directory, so I'll slurp it down. And we don't have a version pin latest. This will probably work. Extract it. Go into that folder. Then we get to build it from source. Cool. And this is the library that actually figures out what part of the sky we're looking at and gets our orientation. Because you can kind of like make the robotics of the telescope point towards a place, but you actually figure out exactly what you're looking at by looking at the stars themselves. Which is totally possible using math. And this wonderful library. You can go look at it. You have astronomical imaging of the sky with celestial coordinates. You do not know or do not trust. Input an image and we'll give you back astrometric calibration metadata. An interesting way to introduce it. Look at the people involved. Gallery. Oh, neat. This is the kind of stuff it does. You got a picture. It looks for things. It tells you about those things. And since we want to know what stars we're looking for planets around, this is really important stuff for us. But it'll be building for a little bit, because building things, libraries from source, can take a little while. And also, like, it just generates so much output as they're building. Hey, they built. Kinda. Maybe? Probably? Let's find out. Let's move on to the next step and see if it doesn't run, then we'll know that this one probably didn't work. Make py. This is going to be building out all those Python bindings for this. And it didn't work at all. No module named numpy. Why? Oh, am I not using my con environment? That's what's up. what we want to do is we want to activate this environment so that we actually get NumPy. Where are we? We're still in the astrometry stuff. Let's go ahead and make py, because now we'll have NumPy available. And it still got grumpy. Do I even remember Python? Nope, no NumPy. User Panoptes Anaconda 3 pip. Why is there no NumPy? I guess we'll just go ahead and install it. I don't know if it's installing this for the entire Anaconda or if it's installing it for just this environment. I actually don't really know Conda all that well. But it's installing stuff. Which Python, am I running the right? Okay. Python. Import NumPy. Hey, it worked this time. How about SciPy? Doesn't work. How about Jupyter? Install SciPy, then Jupyter. Let's see if this works. And I don't actually know if it's installing it just for this environment or if it's like globally within this particular Conda installation. But honestly, either one's sufficient. Ooh, we get 0MQ. Bunch of stuff. QT again. All sorts of stuff. So now I bet this make will work. Are we still in the right path? We are. Looks like it's continuing to run. Yay! I don't know if I over aggressively installed things or just aggressively enough installed it. Some of the stuff was built for newer than being linked. Okay, so because that's okay. Well, these. So it looks like I pulled in some binaries from 10.7. I don't know if those are gonna work. Well, one way to find out. Let's keep going. 10.7 was like, what was that, leopard or something? That's like an ancient version. Lion. Ooh. 2011. Hopefully I'm not pulling in like lion age binary. No errors yet. Be done, nothing be done. Seems like it's doing stuff. Okay, so there, can remove those binaries, all that installation stuff. That means I should have all of the astrometry library stuff set up, which is a bummer you have to build it for. It'd be cool if it was like available as a package or something, but that's okay. So now we have to clone these repositories. Let's go into our Panoptes directory. We are in the Panoptes directory. Let's clone these repos. We're just gonna go right from head. Someday, probably be smarter to pull from some kind of version or branch or something. We're going to clone the administrative website, which is kind of a little website that runs on the device itself, on the telescope itself, so you can do simple administration tasks. Now let's That looks like the right pip. Let's install all of the modules we need, all the Python modules we need. Astroplan, AstroPy, all sorts of stuff. Where did the POCS environment variable set? Is that up here somewhere? Oh yeah, there it is. But we're getting really close. And I think all the fumbling around I did last time with Mongo wasn't really necessary because the POCS will actually fail over to like a local file system distance. Which is great for development. The cron token. Peek ahead. There's some tasks that a running unit needs to run a regular interval. We can see the kind of scripts it runs. Plot weather and data. First time we'll plot weather information every 5 minutes. Second, we'll download the coordinate database every Sunday. Let's take a look at that data.py. That within POCS, fills data, and this is getting kind of the observation. Oh no, this is the astrometry file. Cool. So back to our installation guide. We just ran pip install requirements.txt. Now we're going to run setup.py install. Then we're going to go to the administration website. And we're going to do another big pip install. Which doesn't need very much because it's just a little tornado web server. Now what we're going to want to do is go get the map of the sky. Essentially, all the data that the astrometry stuff needs to function. And apparently the way it does it is it downloads a bunch of FITS files. And FITS is a special image format used for astronomical data. It's really cool. It has like all sorts of doesn't assume Cartesian planes. You can have curved surfaces and different representations of the raster data inside. It's a really cool format, very expressive. So let's see if some of these things can actually run. So what happens when I try and run the weather stuff? It's going to be like, no module pandas. Well, let's install pandas, which is another math library, essentially. So we're installing pandas. Its dependencies. Now, can it try and plot the weather? So it's retrieving data from Mongo, but I don't have a Mongo. It's actually go look at plot weather. That's in POCS script. And it's important for these telescopes to know what the weather is, because if it's raining or something, they don't want to try observing. Not worth it. This is under... Yeah, and it blew up because it couldn't connect to... Not surprising. So once it's set up, what else can I actually do? I've done installation. I want to test it. So I guess we should run some of the tests. These take a little while to run. So where am I? I'm in POCS. We're just going to run some of them just to make sure that some of the system. Oh, we can actually look at the output while it's running. I love how it doesn't save. And then like when I make the font bigger, it makes my terminal window huge. I'm gonna fix that real quick. Go into my appearance settings. I want big text. Well, where's my text? There it is. 12. No, we got big monitors now. And we have cool font. Not Menlo. Menlo's a nice font. I like free code as a ligature. There, it's nice and big. Anyway, as I described, what we can do is switch over to Panoptes. Okay, so now I'm me. Okay, so now I'm Panoptes and my environment's set up properly. So now I should be able to tail that log and see it doing stuff. So, oh, the log files changed. So what we probably want to do is we have a bunch of files. They're very long file names because they're all I guess. So I guess we want to look at that one. Oh, there we go. We can see it doing stuff. Oh my gosh, it's doing stuff. Cool. And we can see it testing stuff. And some of these are going to be skipped or failed because like there's not actually a camera or any electronics plugged in. That probably needs to be changed. PyTest all. That long. There we go. I'll update that README. Feel the output. Great. An actual hardware. So while those tests are running, booping away in the background, let's see where we can kind of move on next. What's the next thing we can do? Coding in Panoptes. A lot of the same stuff. While doing development, it is often easiest to use the object interactively. Jupyter can help us do that. And there's example notebooks we can play with. Let's go ahead and play with these. So normally I would run through all the tests, but I know they take like 10 or 15 minutes to do the whole test suite. So we're just gonna bail on that. We're just gonna run the jupyter-console. See if it starts up. I know there's a really cool simulator. You can like walk through a state machine on a virtual telescope, and I wanna see that. I want some more satisfying thing than seeing some unit tests run. But doesn't seem to be running anything. I would assume it would pop up like a Jupyter. Give me a path. Oh, okay, so it's a shell. Hello. It didn't work. Why is that? I'm in POCS. Now I want to run jupyter-console. Let's see, where is it running from? That looks like the right place. But it gets grumpy. Why are you grumpy, jupyter-console? So it is grumpy because big error, kernel app, so not IO loop, IO type object IO loop has no attribute initialized. Well, that's a bummer. Project Jupyter, which is great. You can do notebooks and stuff. I've never used the jupyter-console before. See if we can figure out what's up with that. Boop. Continue troubleshooting. And there's an issue somebody reported once upon a time. Red. You have packages. The output of it freeze. Creating a new virtual environment with only the minimum essential package. But I need those packages to do Panoptes stuff. I don't know why it's grumpy. Well, at this point I'm probably going to poke. I wonder what just happens if I bring up Python and try and run stuff. Like the regular Python REPL. Is that the right Python? It is the right Python. Let's bring up a regular Python REPL. Let's pull in POCS. Let's see what happens. I'm assuming this assumes it's running in a jupyter-console. You're missing one positional argument, observatory. So let's go take a look at yes. So from POCS core, import POCS. So go take a peek at core.python. Whoop. Import POCS. And pan state machine, pan base. The main class representing the observatory control software. And what did we pass it? Per this, we passed it simulator. And it said missing one required positional parameter. And in an instance of the POCS observatory class. Give it a self observatory. State machine file and message. And it just assumes it asserts it has an. Let's go see what we can give it. So observatory is in POCS observatory. So it sets up the observatory, reads the config file, sets up location, dates, mounts, cameras, and weather station. Is there like a sub one? So I guess I need to find implementers of this. I can find a simulated observatory. Well, I think I'm kind of at the end of the instructions now, so I'm probably going to stop on this task for the day. It was fun, so we made it a lot further. The test ran. I'm probably just going to run the rest of the tests in the background, and we'll see where they go. Then I'm going to chat with my peers on the project and ask them what to do next. Like, should I get the Jupyter notebook stuff bugged and fixed? And oh, here we go. This is from observatory. So from my, where did that go? It was back over. From POCS.observatory or observatory. I can probably just create one. Use simulator equals mount for simulator. Oh, it crashed my Python. That's pretty cool. Terminating. Mount port not available. Use simulator equals mount. Let's run Python again. See if we can get this created. Simulator equals mount. Is it a string? No, I didn't like that. Is it symbol? Yeah, I wouldn't know how to do that, would it? Unless it got defined by me doing that import. Oh wait, here we go. Yay, now we have an observatory, which means we can go back and we can do the, we can set up the rest of the observatory control. And it needed an observatory. And then like that. Oh, so first I have to import. Since my interactive shell broke. And hey, I have a POCS now. The examples and notebooks to see what other cool stuff I can do. Let's go look at that. We want to go to POCS, samples. Nope. Scripts, resources. Reno files, targets, scripts. Oh, here, examples notebooks. It's in a different color. I passed right by it. And here are Jupyter notebooks, which is why I want to do this in a Jupyter shell instead of just in like random Python shell. Oh, there's an initialization program. Let's see if my POCS will initialize. Hey, it initialized! Yay! Woohoo! And I can see what I'm observing right now, which is nothing. Yeah, if I actually had the Jupyter stuff set up right, this would not be as weird as I'm doing right now. Let's get a fake observation. It's doing something. I don't know what it's doing. It got a new observation. Let's take a look at it. Hey, we have an observation object. We have a 2-minute exposure. In this case, it was looking at Kepler 1100. What are we looking at here? WASP 11. I'm assuming that's a star. It is a binary star consisting of a magnitude main sequence orange dwarf and an M dwarf with separation of 42 astronomical units. looking at about 440 light years away from the constellation Aries. Ooh, okay. So that's just like, you know, big data that got inserted. So we can set a target. In this case, we're looking for super gravitational wave event, because gravitational waves are pretty cool. And we can change our target to that location, and we can observe it. So again, it's going to run for the same number of seconds it ran last time. It's simulating it, but this is actually when the camera shutters would be open and it would be looking at that place in the sky. And now we can take a look at that observation. There's all still simulated data. Oh wait, we just did another. We can remove observations. And we can look at all the observations in the scheduler. That's pretty cool. Make a whole bunch of different stars. And 5, WASP 46, all sorts of cool stuff. Okay. Yay. Okay, so that was fun to run through. Great. So on that note, I'm going to call today. So I don't know how interesting the stream was to watch, but thanks a lot for tuning in. It was definitely enjoyable to fumble around with the software. And I guess I will see all of you in a future session, probably next week. So thanks for tuning in and have a great rest of your code-infused day. Bye, everybody.